Welcome back. Today, guys, we are going to talk about our last part of ionic bonding. And that's going to be what we call variable charge ion, which we find in the transition element. These are probably the hardest section we've talked about because there are actually a few things that you have to memorize. Yes, memorize things. I know you don't like to do that, but in order to be successful in this, you have to memorize a few things. It's only 4 things, so it's not too bad. So come along with me on this. Okay, first of all, we should refresh ourselves where the transition metals are. They're right here. Remember, we talked about the D block elements. We talked about electronic configuration. And we're also going to be adding 2 more, tin and lead to these. They're not transition, but they do fall under the variable charge. Now, we've already talked about 3 elements in the transition elements. That was gold, zinc, and silver, right? We said silver has a +1 charge. Gold has a +1, and then zinc has a +2. And we said one way to remember these is that gold and zinc are both in the 1B, and then zinc is in the 2B. It has nothing to do with what their actual charge is, but it's a good way to remember those. So you do have to have those memorized. Now what we're going to start talking about is the rest of the elements in the transition. Okay, the transition, remember we said it's in the middle, it's the D block. And the difficult thing with these is we can't predict them like we did with the A groups, so 1A, 2A, 3A, 4A. They don't work quite the same way. They have a lot more going on with the electron configuration. So what we actually find with these elements in the transition is that they have more than one charge. For example, if we look at iron, Fe, iron can have either a +2 or a +3 charge depending on what's going on with it. So we must have to figure out a way to determine, do we have the +2 or +3? And unfortunately for you, you're going to have to memorize what we call the table of variable charge ion. This is on the back of your polyatomic sheet. So if you go get your polyatomic sheet right now, wait. Okay, now that you have it, look on the back, the very top of those say variable charges. And it should look something like this. Okay, you have 3 groups. You have a +1, +2 group, a +2, +3 group, and a +3, +4. If you look at it just on the back of your polyatomic sheet, it's pretty intimidating. I'll show you an easy way to memorize this after we talk about this. First of all, let's look at the +1, +2. There's 2 elements in here, copper +1 and copper +2. And then there's mercury. If you notice the mercury, they're both a +2 charges. The difference is this little chart 2 right here. So think of this Hg2 as 2 Hg +1s put together. So we call this one the lower charge, this one being the higher charge. Okay. Our group 2,3 is chromium, manganese, iron, cobalt, and nickel. And then finally our group 4, our last group, the 2,4 is tin and lead. Here's how I suggest you memorize this. If you can memorize that copper and mercury are in the 1 and 2, and then memorize that tin and lead are in 2 and 4. If it's not copper or mercury, it's not tin or lead, it must fall in this middle group. So you're only really memorizing the charge for 4 ions. Copper and mercury, tin and lead. And if you ask me in class, I'll tell you kind of a little ways to memorize this as well, a little saying I have. So come ask me in class and I'll help you with this. So the first difficulty starts with naming them. As we said, these variable charge ions can be a couple different charges. So their name must reflect what their charge is. So we know if we're talking iron 2 or iron 3, nickel 2, nickel 3, tin 2, tin 4. Okay? So the way we do that, there's actually 2 systems. There's the newer system we call the stock system. That's the one that we are going to concentrate on here, and that's the one that we're going to hold you responsible for. The other one is called the classical system. We'll talk about that, but I'm not going to hold you responsible for that on tests. I just want you to be aware of that, and we'll talk about why in just a second. So the stock system uses Roman numerals to indicate the charge of cation. Remember, the cation is the positive ion. And remember, for variable charge, all of them are going to be cations. There's no negative anions that we worry about. Okay? So remember, you're going to put the Roman numeral after the name of the ion. Okay? So make sure you remember our Roman numerals there. So a couple examples would be copper 1 chloride. There's the name of our ion, right? Remember, we dropped the word ion, just put the name of the element. There's our charge. That's a copper +1. Copper 2 chloride would look something like that. So it's really easy. You just got to figure out what the charge is and put that charge in Roman numeral after the name. And then the anion name is the same as always. Here's another example. Tin 4 oxide. Hopefully by now you all know your Roman numerals. If not, come see me and I'll help you with that. Alright, so the first thing we have to do before we can determine how to write the name is we got to determine the charge in the atom. The way we do this is by doing a reverse crisscross. So let's do this example. We got Fe2O3. Okay, we got to remember iron. What can it be? Well, it's not mercury or copper, so it's not the 1 or 2. It's not tin or lead, so it must be in that middle category, 2 or 3. A lot of you are looking, oh, there's a 2 right here. It's got to be iron 2. But you got to remember, how do we get this? Well, we crisscross to do that. So to figure out the charge of iron, we do a reverse crisscross. We look at our subscripts and then reverse them, put them up there. In this case, what we find then, an iron, Fe is a +3, and then oxygen is a -2. Now, oxygen is not variable, right? It's always going to be a -2 charge. So when we write this then, it'd be iron 3 oxide. So we'd write it like iron 3 oxide. Try this one here, copper chloride. Pause the video, try this one on your own. Alright, we know there's no subscripts down here, so when we crisscross them, must be 1 and 1, right? Well, we know chlorine is a -1, so it's normal, so it's copper 1 chloride. Okay, here's the other version where we have a 2, right? The 2 had to come up from here, so in this case, it's copper 2 chloride. Okay, what I want you to do, I'm going to show you this next example. I want you to pause the video and then figure this one out. So we have FeO. Pause the video and do this one yourself. Alright, let's see if you're right or not. So, first thing we have to do is do our reverse crisscross. We get each of these a 1, right? But what do we know about oxygen, right? We know, as we saw up here, oxygen is always a -2. So the question is, why then is there nothing down here? Well, remember, when we crisscross, coming down from the top, normally the same number, they cancel each other out. So in this case, it's going to be iron 2 oxide, because the +2 from the iron and the -2 from the oxygen cancel each other out. So that's a little tricky. You got to keep aware of this. So that's the only little thing that makes this difficult. Okay, the classical system. This is the other system that we use. And the reason we teach it to you, because if you walked into our chemical stock room right now, you would see both the classical system and the stock system used. So I just want to make you aware of this. I'm not going to test you on this, but I wanted you to be aware of it in case you see this elsewhere. So what the classical system is going to do, it's going to use the root word of the name, and then it's going to end suffixes. So remember, suffixes are things that go in the end. So the higher charge are going to use the stuff ic. Okay. The lower charge is going to use the ending us. Okay. For example, the other problem is that some of these go back to the elements go back to the Latin name. So, for example, copper goes to cuprum, lead goes to plumbum, tin goes to stannum, and iron goes to ferrum. Why? Because it's been done so long that we take it. So the way I remember this, think about when you were a little kid. You wanted a snack, right? Mom didn't keep the nasty chemicals down low. Okay, she kept the bad stuff up high. So the stuff that was for us, she kept down low. The icky stuff that she didn't want you to eat, she kept up high. That's how I remember it. The stuff for us goes down low, the icky stuff goes up high. Okay, so we used to have you memorize these, but we're not going to worry about that anymore. So let's a couple examples here. FeO, we just did this one, if you remember right. We said this was the iron 2, so 2's the lower charge, so this is actually going to be ferrous oxide, lower charge. If we had the other version of this, Fe, right, 3 came from here, so it's a higher charge, it would be ferric oxide. Let's look at copper. We did this one. This was the +1 charge, which is the lower, so it would be cuprous chloride, going back to that Latin name, or the other version is going to be cupric chloride. Here's one of my favorite ones, NiBr2. Nickel, 2, well, nickel is not tin or lead, and it's not mercury or copper, so it's got to be in the middle, 2, 3, so this is the lower charge, so what do you think it'd be? Nicholas bromide. Okay, or we could have the higher charge, which would be nickelic bromide. Now I'm not going to test you on this, but I do want you to be aware that this system is out there. It was a much older system. Everybody is switching to the newer system, but we still see stuff out there for this as well. So just wanted to make you aware of this. So once again, there's our variable charges that you need to know. Memorize copper and mercury are +1 and +2, and then tin and lead are +2 and 4. And if it's not one of those 4, it must be in the middle. Remember, Hg with the little 2 here, that's our lower charge. So this would be mercurous, this would be mercuric. Okay, if we do in the classical system. I won't test you on those, but they make really good extra credit, the classical naming system. Okay, last thing I want to do is I want to do a review on salts. Remember, salts are simply ionic compounds. It's a generic name for any ionic. We started talking about the binary ionic compounds, and this is made up of two elements stuck together. And you're going to have a metal plus a non-metal. So if one comes from the left, one comes from the right side periodic table, you're going to know it's a binary. Polyatomics are made up of 3 or more elements. So for our class, anytime you see 3 or more elements in a compound, you're going to know it's a polyatomic ion and go to your polyatomic sheet. And then today we talked about the variable charged ions. Remember, the cation variable is from that transition group, that middle group. So once you see it there, start thinking, okay, when I name it, I have to put the Roman numeral in to tell what charge that is and do the reverse crisscross to figure that out. Alright guys, so that's our end of our first part of the bonding unit with binary. We'll have a test on this, and then we will come back and start talking about covalent bonding and a little bit of organic, and then we'll put them all together for a big test. A big important thing that I can tell you is do not forget what you have already learned. That's where people get confused. When we go to covalent, they start bringing in binary or ionic rules to it. They keep them separate. Okay, so review your notes on polys, binary, and variables, and be ready to go. Once again, if you have any questions, please come see me, and otherwise, I'll see you in class. Take care.